Hello everyone, I am Mrs. Lim and today I'll be introducing in this video about the turning effects of forces, or we call it the moments. So in this video, we will be covering what exactly is moments and how do we calculate moments. So the learning outcomes are as follows. Okay, so we have always tried to use a spoon to open a lid of a tightly closed tin of cereal or any tins, okay? And we always find that if we use a longer spoon, it is easier to lift off the lid. And why is this so? I hope you'll be able to answer this question at the end of this video. Okay, so whenever we use a spoon to lift the lid, we exert a force on the spoon that looks like in this diagram. Okay, I exert force, so this orange bar looks like the spoon. Okay, and it causes a turning effect. The spoon will turn about the edge of the tin, and the load is actually the lid of the tin. So this turning effect is also known as moments. This turning effect is the one that causes your lid tin, which is the load over here, to move up and open the lid or open the tin. Okay, so when you exert a downward force, this whole spoon rotates or turns about the pivot and causes the load to move up. That's why we call it a turning effect or rotating effect. So this rotating effect is called moments. So moments is best shown using a simple lever. And in a simple lever over here, this is the diagram of a simple lever. You have it resting on a pivot. Pivot is like the fulcrum, is the point where the bar rotates about. Okay, and then it's often used to move a load when a force is applied. So how do we calculate moments? Okay, the moments of a force, okay, we represent it by letter M, big letter M, or we call it the torque about a pivot is the product of the force and the perpendicular distance d from the pivot to the line of action of the force. Wow, it looks like there's a lot of bombastic words, okay, but we'll go in depth into what it means later on. So in short, the formula is moment, M, big M, equals to force times perpendicular distance. And then the moments have SI units of Newton meter because it's force times distance. Force is in Newton, distance is in meter, so it's Newton meter. And it's a vector quantity, but we'll talk about directions of moments later on. Okay, so it says that I need to multiply the force by the perpendicular distance. So what does the perpendicular distance means? It simply looks like this. So this is my pivot or my fulcrum, and I have a force A exerted over here. So the line through which the force acts on, okay, this dotted line over here is called the line of action of force. Okay, so it's like just like I extending out the force, okay, to this dotted line. So this is the line of action of the force and the perpendicular distance to the pivot, okay? So it says that the force multiplied by the perpendicular distance between the pivot and the line of action of the force, this will be the perpendicular distance. So I draw my force line or my line of action of force, and it is 90 degrees to it and to the pivot. So this will be my perpendicular distance. I'm going to give you more examples. So for example, I have a force A over here. So this will be my line of action of force A, and my perpendicular distance will be over here. Perpendicular distance between the force, 90 degrees, which is 90 degrees to the force, to the pivot. And if I have my force B over here, then my line of action of my force will be here, okay? And my perpendicular distance will again be 90 degrees to my force. So my perpendicular distance is in this direction, the pivot. And if I have force C over here, then this will be my line of action, and this will be my perpendicular distance. Again, is 90 degrees to the force, okay? So, but sometimes the force may not be perpendicular to the bar. So in this case, for example, over here, we have force A that acts in this direction on the wooden rod or on the bar. So how do I determine the perpendicular distance? The same idea follows. So the first step, I need to extend out this force line to give me my line of action of the force. So my line of action of force will be along this dotted line over here. And then my perpendicular distance will again be 90 degrees to this line of action of the force. So 90 degrees to it, this will be my perpendicular distance. It's the shortest distance. Okay, this is my perpendicular distance to my pivot. So it's at right angle. Okay, so this will be my perpendicular distance. Okay, next one. You may pause the video to think about what is the perpendicular distance for this force. Okay, I'm going to go through now. So again, the first step, I draw the line of action of this force B. It will be this red dotted line, and then the perpendicular distance will be 90 degrees to this line of action of the force. So it will be this distance over here, 90 degrees to the pivot. Okay, I have a GeoGebra simulation. You may scan the following QR code, and then you can vary the force direction, the direction of the force. Okay, and then you can actually show the perpendicular distance and show how do I calculate the moments. Okay, I can vary the length of the force, vary this arrow, so I can vary the quantity of the force, and I can also vary the angles. Okay, so you can play around with it to understand more about what is line of action of force and what is perpendicular distance and how do I calculate moments. Okay, so based on just now that formula, moments is the force times the perpendicular distance between the line of action of force and the pivot. We know that the turning effect is directly proportionate to the perpendicular distance and to the magnitude of force. So it simply means the larger the distance, the larger the moments, the larger the force, the larger the moments as well. Okay, so this turning effect is also known as torque. Okay, and so we come back to just now the example of why is it easier to open the tin lid using a longer spoon. So when we use a longer spoon, what are we increasing? We apply the force at the end of the spoon. So with a longer spoon, the perpendicular distance between the pivot, which is the edge of the lid, to the force or to the line of action of the force will be greater if I use a longer spoon. So with a larger perpendicular distance, I will have a greater moment or a greater turning effect. So with a greater turning effect means that the rod will turn even more. So it is easier to lift up the lid with this longer spoon. Okay, so next we move on. After calculation of moments, we move on into moments is a vector quantity. Okay, so a vector quantity has got not only the magnitude, which is force times distance, it also have a direction. So how do I go about knowing the direction? For moments, there is only two types of moments or two types of direction, because moments is a turning effect. Okay, so the turning can either be a clockwise moments or anti-clockwise moments. So a clockwise moments means I follow the direction that a clock's hands move. So it moves clockwise means it moves in this way. Okay, so over here, this picture over here, I have my pivot here. I have my force here. So if I exert a force downwards over here, my rod will turn this way. So it's in the same direction as how your minute hand or hour hand move in your clock. So it's called clockwise moments. And if my force is going upwards, then this rod will move anti-clockwise. It will rotate upwards. So it's anti-clockwise moments. Okay, so now you may pause the video to think about the direction of the moments for each of the following case. I'm going to go through now. Okay, so the pivot is over here and the force is over here. So what happens if this thing will be rotating in, let me draw, this thing will be rotating in this manner. Okay, so this manner, it will be an anti-clockwise moments. Part B, the pivot is over here and the force is over here. So this rod will be rotating this way. It will again be an anti-clockwise moments. Okay, and then next, I have the force is exactly at the pivot. Okay, so at this point of time, you must know that there is no perpendicular distance. Okay, the force is here, but there is no perpendicular distance to the pivot. So my perpendicular distance is 0. I will actually have no moments at all because force times 0 is 0. Okay, so there is no moments at all. So this bar will just move up. It will not rotate. It will just move up because of this force. Okay, and then next I have this force over here. So this will actually cause the rod to turn in this way, which is a clockwise moment. Okay, then let's take a look at example where I combine both the magnitude and direction together. So you have a rod which is 3 meters long, and it is pivoted at the middle. So at the middle will be 1.5 meters. If he pushed down with a force of 50 newtons, what is the moment he produced? And state the direction of this moment. So I have a force that's exerted over a perpendicular distance from the pivot. Okay, so I will have a moment. So my moment is defined as force times distance. Okay, my moment is force times distance. So my force will be 50 and my distance is halfway because my pivot is in the middle. The entire rod is 3 meters. So my moments is 50 times 1.5. I'll get 75 Newton meters. And because of this force, my wooden rod will turn in this way. So it will be clockwise. The direction of the moments will be clockwise. Okay, next question. A door is hinged at its edge. A girl opens it by exerting a force of 10 Newton on the handle located at the other end over here. Determine the moments due to the force exerted by the girl on the door. Okay, so in this first case, okay, I know that this door will rotate about the hinge. So the hinge is actually my pivot. The object always rotates about the pivot. So the pivot in this case will be the hinge. Okay, and then next, I need to know where is my perpendicular distance. I know that I exert a force of 10 Newton. So my 10 Newton is exerted on this handle. Okay, so my force is exerted like outwards of the paper or inwards into the paper to open this door. Okay, so 90 degrees to it, to this force will actually be this distance over here, which is 1 meter. Okay, it's not 3 meters. Okay, so my force, I can't draw 3D, so my force is like that, outwards. Okay, and then 90 degrees to this force will actually be the 1 meter distance of the door. Okay, so next I move on to calculate moments. I give me the formula. Moments is force times distance. So my force is 10 newtons, and the distance that I apply it, or the distance between the force and the pivot will be 1 meter, not 3 meters. 3 meters doesn't reach the pivot at all. Okay, so it will be 10 times 1 meter. I'll get 10 Newton meter. Next one, let's think about this. Is this the best way to position your clothes if you are hanging your clothes out to dry on a bamboo? Okay, I'm going to go through the answers now. This is definitely not the best position. Why? Because your jeans is much more heavier than your small handkerchief. So what happens here is your jeans have a large weight, okay, because it's very heavy as a large force. And where is your pivot? Your pivot is the point where the hand is holding. This entire rod is moving up or down about the hand. So the pivot is over here. So this large force is exerted over a large perpendicular distance. And this is very bad because this will give you a very big moment as compared to a small force over here with a small distance. Okay, this will give me a very small moment, but in overall, when I add up everything, the red color moments plus the blue color moments, I get a very large moment because of this red color one. Large force, large distance. So what could I do better is I could have changed. I could have put the small handkerchief at the end and my jeans nearer to it. If I put my jeans nearer to the pivot, then although I still have a large force because the jeans is too heavy, but a large force times a small distance, the perpendicular distance decreases, I get a smaller moment. Okay, with a smaller moment, this bamboo stick would not turn so much. The turning effect would be reduced. So it is actually easier to rotate or to turn this bamboo stick about. If you have a very large movement, then it's very heavy, it's very difficult to turn this bamboo stick, and we don't want that to happen. Okay, so the answer is bad. Okay, this is just the first part of the video. We will stop here.